हेलो स्टूडेंट्स, वेलकम टू SQS क्लासेस। आज हम प्लस 2 का एक वीडियो बना रहे हैं और इसमें NCERT CBSE सिलेबस एक्सरसाइज 1.2 here functions 1 on to. If 1 and on to both, then bijective. 1 means injective and on to means surjective. So about these questions are there about the function. So today this question number 3 of exercise 1.2, prove that the greatest integer function f real number to real number given by fx is equal to greatest integer function is in neither 1 nor on to. We have to prove. Now proof. Yes, about this first 1 we have to check 1. So now for 1 always we are taking x1 x2 two elements in the domain set. Domain is real number. So let x1 less than x2 and different, comma x1 comma x2 belongs to domain set. Domain set is real number set. Real number set always such that image means fx1, image at x1 is equal to image at x2. Let us suppose that x1 x2 are the different, x1 less than x2, different input domain element, such that the image on both are equal. This is the standard method to prove the 1 for every types of function. Take two elements x1 x2 in the domain and take different and such that कि उनकी इमेजेस इक्वल हैं, उनकी इमेज इक्वल है, आउटपुट इक्वल है, इस तरह हम लेते हैं. ओके, दिस इज द स्टैंडर्ड मेथड टू चेक द 1 and then implies that according to the given function, what is the nature of the function? Given function, it is greatest integer function. So now fx1 will come greatest integer of x1 is equal to fx2 greatest integer x2. Okay, now understand this. Now greatest integer x1 value, we know greatest integer definition in +1. I want to explain that greatest integer x is equal if x greater than and equal to 0 and less than 1, then this value is 0. If x value greater than and equal to 1 and less than 2, then value is 1. If x is greater than and equal to 2 and less than 3, so between two integer nearest, then lowest integer is the solution of the greatest integer of that number. So greatest integer of x is defined like this, we have done in plus 1 and so on, and up also similarly. If x is greater than and equal to minus 1 and less than 0, okay, then less than and equal minus 1, then it is minus 1. So similarly up and down. So output here any range. What is the range of greatest integer function? Range of the greatest integer function, these output all integers, 0, minus 1, minus 2, minus 3, minus 4, and 1, 2, 3, 4, 5, 6, like this, and so on. So like this, if input between two integers and lowest integer with that, and equal in the lowest and up only less than, so means from 0 to less than 1, from 1 to less than 2, from 2 to less than 3, like this definition of the greatest integer function. It is in plus 1. So use here this definition to find x1 and x2. x1, x2 we are taking any two in different real number. Ab real number means you can take any real number if you want to take any that. If let us suppose you are taking between 2 and 3, other between 3 and 4, means they are the different. Many real numbers are there between two nearest integer. Infinite real numbers are there between every two integer. So from infinite integer may be any this x1 and maybe any x2. So lowest integer, let us suppose these are integers taken that, so x1 and x2, x1 is less than x2, so then let us suppose this value is here at x1, if x1 x2 belongs to integer, okay, belongs to integer, every integer also real number. So implies that solving this, what is that? This integer value as it is integer, x1 is equal to x2. First case, if x1 comma x2 belongs to z, integer. Second case, if real number between any two integer, x1 x2 two integer, and between that if x1 less than 1, if less than 1 and greater than 0, let us suppose this, if this case, then in this case what will come? x1 this and x2 between x2 let us suppose greater than 2 and equal to 2 and less than 3. Let us suppose this. So what is this? Solution, x1, greatest integer x1 for this case, it is less than 1 and greater than equal 0. So less than 1 and greater than equal to 0 means 0. So this value will come 0. This value will come 0 and this value will come x2. x2 is between 2 and 3. Let us suppose then 2 will come. So these are not equal. Understand? So means okay, if x1 x2 both are the same, then let us suppose x1 is an integer and x2 in between. Third case, in this case this, okay, here less than everyone will be 0, x2 is this, so x1 x2 in one case that taken. Then this, if we are taking x1 is greater than and equal to 0 and less than 1 means x1 this, and x2 also. Example taken if, because it will fall. One example, because you see that if x1 taken is equal to 0 and x2 taken different number taken, then taken 1/3. Let us suppose between 0 and 1. If, so for this example, these will not be images. So x1, तो greatest integer of 0 क्या इक्वल है या नहीं, चेकिंग. ग्रेटेस्ट इंटीजर ऑफ 1/3. तो ग्रेटेस्ट इंटीजर ऑफ 0 is 0 is equal to greatest integer 1/3 also 0. True. So means x1 is equal to x2. So if these are different, then these are different, then these are not equal. It means for this example, if this we are taking, this example taking, तो image of both if equal, तो यहाँ equal है ही नहीं image, तो ये different number पर image same नहीं है यहाँ पर, और different image पर different numbers पर x1 x2 image same, तो means that must be same image के लिए वो same. and यहाँ example क्या हुई कि different है तो भी उनकी इमेज सेम है. इट मीन्स फॉर दिस कि डिफरेंट वी आर टेकिंग एन इमेज सेम, तो मीन्स इमेज सेम ऑन द डिफरेंट इट इज many one. So it is many one. Understand? It is many one. It is not 1/1. And it is many one. Why? Because different x1 and x2 taken and image is same. So it is many one. यानी greatest integer of 0, this output this 0, this, so means this is equal to 0 and greatest integer of 1/3 also 0, means we can say from this example कि then 0 associated to 0, x element 0 associated to image 0, and then 1/3 also associated with 0, means many one. From this example this is clear that it is not 1/1, it is many one, because different input output same, different input output same 0. So many example like this are there. So input for different two input images same, so it is not 1/1 for this example, so it is not 1/1. So give example like this for the false. Okay, it is general case, but here for examples we can say we can show that it is not 1/1. We can take general this, which example I taken exactly, we can take any C and C between any two integer, we can take like that. Okay. Now after that on to we can discuss output range. Find the range. Find the range. Now what is the range of this? We know greatest integer function range. Okay. So y is equal to fx is equal to greatest integer x. This is your function. Now means y is equal to greatest integer x, and is equal to set of all integer, set of integers, set of all integers. Set of all integer means y belongs to z. This implies range set is not equal to codomain. Codomain set is real number set. Second set is codomain set, and range also always in the second set. So if range is equal to the second set codomain set, then then on to. If range not equal to codomain, range set is not equal to codomain set, then it is not on to. Hence greatest integer x, hence this function, greatest integer x function is neither 1 nor on 2. Hence proved. Okay, now next question. Modulus function. Yes. Now next question. So that the modulus function. Question number 4. So that the modulus function such that R to R given by F, such that real number to real number given by fx is equal to modulus x. This, okay. Now this function we have to show that modulus x this neither 1 nor on 2, okay, is neither 1 nor on 2. Okay, greatest integer function also we have read the definition in +1. What is the definition of greatest integer function? Definition of greatest integer function: greatest integer x output if x equal to 0, then greatest integer actually 0, then 0, then modulus of x is 0. Sorry, modulus x. Okay, now if x less than 0, negative, less than 0, negative real number, domain x. For every negative number x, if negative, so what will come? Value of the modulus of negative number multiplied by the negative of the negative x, then minus of x, because x is negative itself. For example, specific modulus of -5 is equal to minus multiply -5, then is equal to minus +5. Understand, if x is -5, then modulus of -5 minus multiply to -5. This is output and it will be positive. So minus x is positive. Minus x is positive because x is negative. For every x less than 0 real number, modulus of x value is minus of x, then it is positive. Okay, understand, this is in +1. If x is greater than 0 for every positive real number, greater than 0 for every positive real number, modulus of x is x, as it is. Okay, these three cases are there. For full domain, all real number divided into 3 parts. One is equal to 0, other is all negative real number less than 0, and other all positive real number greater than 0. So then these three outputs are there. Now for this proof, yes, so for proof, let x1 less than x2, comma x1, comma x2 belongs to domain real number such that standard method such that output at x1 input is equal to output means image, output image yani f of x2. If these are equal, this implies if putting here x1 x2 are any real number, x1 x2 different real number, so different real number, understand that different in real number. So if I am taking here less than 0, different real number taken, different. So x1 if less than 0, x1 and x2 also less than, both are if negative. If both x1 x2 less than 0, any negative real number. Okay, if in this case if both are negative, so multiply by the negative of this, and minus x will come, then this implies minus x1 is equal to minus x2. Okay, then if x1 x2 less than 0, understand, so if x less than 0, so minus of that x. So if x is x1 and here x2, then minus x1 minus x2. After that, for this case, minus x1 equal minus x2. Okay, minus minus cancel, so then x1 is equal to x2. In case first. If case second, if greater than 0, if both positive, x1, x2 both greater than 0. If in this case, what will be? f of x1 in this case पॉजिटिव नंबर है x1, तो मॉडुलस ऑफ x1 इज x1 एज इट इज इक्वल टू मॉडुलस ऑफ x2 इज x2. देन ओके. थर्ड केस, if x1 less than 0 and if x1 less than 0 and x2 greater than 0, in this case less than 0 x1, तो fx1 minus x1 is equal fx2. x2 is positive, then positive modulus is positive. Then this case, hence it is not 1 1, these are different. x1 is equal to x2. So from this case, so this function is not 1 1, is not 1 1. Example, if x1 less than 0, I am taking minus 2. So this is not equal, this positive, any positive we are taking positive any, then I am taking positive 1. So greatest integer of minus 2 is 2, not equal to 1. Okay, now we have to say any two input having same, any other two having the same output. For example, one more example we may give, that here it will be clear कि minus 1 greatest integer of minus 1 is equal to 1 and greatest integer of 1 also equal to 1. So we can say from this कि minus 1 and 1 इनपुट है और इनका आउटपुट आ गया 1. So it is many 1. You can give many examples. 2 and minus 2. 2. Greatest integer of 2 also 2. Greatest integer of minus 2 also 2. So example you can give this for the false of 1 1. For the false, give the example. So this, hence it is not 1 1. After that, range for the onto. For onto, find the range. Output always. So range means y is equal to fx is equal to greatest integer x for every x belongs to real number. For onto. Okay. Now, so greatest integer x की value output. If x is, three cases are there. If x is equal to 0, then 0. If x less than 0, any real number, then minus x, means minus of minus plus x, positive. Then if x is greater than 0, any real number, then x as it is positive. So both are positive. Minus x also positive, x also positive. Because minus x, why positive? Because x is negative. because x is negative in this, so minus x output will be positive. So greatest integer of every negative real number will be positive, and positive output positive. So we can say range is all positive real number. So directly y belongs to, by the definition, y belongs to 0 if x is 0, then 0. So closed interval 0 and up to positive all real number, then infinite open. So this implies range set is not equal codomain. Because codomain real number set, and this is only positive real number with 0. Positive real number with 0. So range set not equal to codomain, hence f is neither neither 1 nor on 2. Hence proved. Okay, now next question. Hello, next question. Generally, I want to tell you if one question we have taken, if f such that a real number minus 2 tends to real number minus, you can write here, defined by fx is equal to x plus 3 upon x minus 2. And x is not 2, and it means x does not belongs to 2, because if x 2 then it will be 0 denominator, so it is not real function. So for the real function we are going to check on 2 and 1 1. Okay, so we are going to check this 1 1 and on 2. Okay, now solution. Check this. Means now we are going to take this function and function value, then same thing, different element. So we can say fx1, directly I am saying, okay, x1, x2 different, we are taking for the 1 1. So I am writing implies fx1 means x1 plus 3 upon x1 minus 2. This is fx1 is equal to fx2, x is x2, then x2 plus 3 upon x2 minus 2. Okay, cross multiply, simplify, then x1 x2 minus 2x1 3x2 plus 3x2 and minus 3 2 ja 6 minus 6 cross multiply equal cross multiply and solve. Then x1 x2 then 3x1 plus 3x1 then minus 2x2 and minus 2 3 ja 6. Okay, now simplify. x1 x2 cancel, same side will come negative. Okay, now take one side x2 and take one side x1. Minus 6 and minus 6 cancel out. Now take one side x1, so minus 2x1 and this plus 3x1 will come this side. Minus 2 and minus 3 minus 5x1 minus 5x1 is equal to this 3x2 will go right hand minus 3 minus 2 minus 3 minus 5x2. Then this implies x1 equal x2. Okay, minus negative cancel both sides, 5 cancel out. Okay, now it means it is 1 1. It is 1 1. So it is 1 1. Now we are going for on to y is equal to fx. Fx is x plus 3 upon x minus 2. Okay, this implies find x, cross multiply yx minus 2y equal x plus 3 equal x plus 3. Now we have to take the value of x. Then x take one side, to take this side x, then y minus 1 common x, yx minus x, x common y minus 1 is equal to 3 and minus 2y will go plus 2y, 3 plus 2y. Then x will be equal to 3 plus 2y upon y minus 1. Okay, this. Now x belongs to r minus 2, all real number except 2. Okay, now what will come y value? X function this, what will come y? This should not be denominator. For the rational function we know what is the value of this domain, and it means y value here. What is the y value? That which should not be 0 denominator. Y minus 1 should not be 0. This implies y minus 1 should not be 0 and y should not be equal to 1 except this, all real number other. So means y, so y belongs to real number minus 1 except 1, all real number. If y 1 then denominator is 0. So for the rational function check the denominator. Okay, always denominator should not be 0, except that all real number is the domain of rational function. So here value of y, so y belongs to this, so r minus this 1. Complete this question, this, check this. So like this is same, what is the codomain set? Same range set. So hence we can say it is on to, because range set is equal to codomain set. So write this, range set is equal to codomain set. This implies रेन सेट is equal to codomain set, because range set r minus 1, all real number except 1. Here codomain also r minus 1 means all real number except 1. Okay, so this function is 1 1 and onto. So f is 1 1 and onto function, hence proved. Okay, now time over. I want to tell you that you are taking interest, you are subscribing and sharing, but comment थोड़ा कम है, तो कमेंट बॉक्स में कमेंट ज़रूर लिखें और सब्सक्राइब करें चैनल को, और ध्यान रखें कि शेयर करना मत भूलें एंड कमेंट करना मत भूलें, और सब्सक्राइब करें जिससे कि मुझे और आगे वीडियो डालने का जो है प्रोत्साहन मिलता रहे, और मुझे ये बहुत खुशी होती है। आपका अच्छा आ रहा है, रेस्पॉन्स बहुत अच्छा आ रहा है। ओके, तो थैंक यू फॉर दिस।